Hello there. Today we're going to continue looking at trigonometric identities. Here are some strategies, and just whenever you're not requested a side specifically to work on, choose either side to simplify and work with. And most often than not, it's a lot easier to work with the complicated side first. Remember, you can work on either side unless it's requested to work on just the left side or the right side. Some of the things you want to make sure you try to do are factor, combine fractions, squaring binomials, and always trying to simplify to create a monomial in the denominator. Whenever possible, try to use those fundamental identities. And thinking of the Pythagorean identities, you can pair up sines and cosines, secants and tangents, cosecants and cotangents. So whenever possible, use those identities. If nothing else works, try converting all the terms to sines and cosines, and then simplify from there. So whatever you do, always try something. These are definitely not going to be easy. Some may be easy, but some may be not. So if you get down a dead end about, with the proof, just try something else. It always helps to go back and redo those proofs. Okay, let's start with the first one. And for all of these examples, what I want to encourage you to do is try the problem. So pause this video now and then restart it so that we can go over the solution. So looking first at example 1 and 2. All right, let's check our answers. So right away you can see the numerator, you have a Pythagorean identity, and then in the denominator we see reciprocal identity, so everything cancels out, 1 equals 1. In example 2, I also worked on the left side. So combining these fractions to find an LCD, I was able to combine those two and get 2 over 1 minus cosine squared of beta. And we can substitute 1 minus cosine squared with sine squared, and we know that's a reciprocal identity, so this becomes 2 cosecant squared of beta. All right, go ahead and try examples 3 and 4. Pause this video and come back to check your solution. Okay, let's go over these examples. For example 3, you may have wanted to FOIL or distribute those and simplify the parentheses right away, but just be careful. We can see some of these Pythagorean identities rewritten, of course, but we have secant squared minus 1, that is equal to tangent squared, and then we have sine squared minus 1 is equal to negative cosine squared. And then we can easily simplify the cosine squareds, cancel those out, and we're left with negative sine squared. For example 4, it may be useful to work with the sum and difference versus the product. So whenever we have a difference here, we can find a common denominator. So I rewrote this as 1 minus sine squared. And then you could see right away that we can substitute that with the identity cosine squared. And then we could break apart that fraction. So it's cosine of x times cosine over sine. And then we get cosine of x times the cotangent of x. All right, go ahead and try these last two examples. Pause the video and come back when you're ready. Now let's check our answers. For example 5, the right side is definitely the more complicated. And it's helpful to know that we're going to have to multiply by the conjugate of the denominator. We're trying to make a monomial in the denominator. So we're going to multiply the top and the bottom by 1 plus cosine of beta. And so on the top, we'll get sine times 1 plus cosine beta. And then 1 minus cosine squared will become sine squared. And then we could separate that into two fractions, 1 over sine of beta, which is cosecant of beta, and then cosine over sine, which is cotangent. For example 6, it's definitely your choice. I would choose the left side because I see that the right side is already in cosine, and so that's really always our last resort, is to change things into cosine and sine. So I want to work with the left side and try to use the identities as much as possible. So I see tangent and secant, tangent squared is secant, and I know that's the Pythagorean identity. So I'm going to multiply by the conjugate again, and so on the top I get tangent squared times 1 minus secant of theta, and then on the bottom 1 minus secant squared, and we know that equals negative tangent squared. So when we simplify that, we just get secant minus 1. And now, as my last resort, I can change those into cosine and then find a common denominator, and I'll get 1 minus cosine of theta over cosine of theta. Now let's try example 7. So pause the video, try the problem, and come back when you're done. Hopefully you saw right away that you can factor out the tangent of x, and then we could substitute secant squared of x minus 1 with tangent squared. And when we multiply those, we get tangent cubed. Go ahead and try example 7b, pause the video, and come back to check your answer. For 7b, you can see right away that we can factor out a sine to the 4th. So we get 1 minus sine squared inside the parentheses. And we know that that equals cosine squared. We put the cosine squareds together to get cosine cubed, and we have that sine to the 4th to match the left side. Go ahead and try 7c. Pause the video and come back to check your answer. On the right side, you can see that you can factor out a cosecant of x, and you're left with cosecant squared of x minus 1. And we know that that's Pythagorean identity. We substitute that with cotangent squared, and then we can combine the cotangents. So we have cotangent raised to the 4th times cosecant of x. All right, go ahead and try our last example for this lesson. Pause the video and come back to check your answer. You may have noticed that this trinomial is a perfect square trinomial, and if it was written with just x's, we would know we could factor that into 1 minus x squared, quantity squared. So we can do the same with this Pythagorean trinomial, and we'll get 1 minus cosine squared, quantity squared. We can substitute that with the Pythagorean identity, and then from there it's just a little practice with exponents, simplifying to eventually get sine raised to the 5th, making that left side equal to the right side. Well, I hope this practice was helpful, and I'll see you in class.